Hi, I hope you're doing well. I'm here with the solution video of paper 11, A and AS level mathematics, Cambridge International, winter 2023. If you like this video, please share with your friends and subscribe to Math United. It will motivate me to make many more videos in future too. Let's get started with question number 1A. Expand this binomial in ascending power of x up to and including x square. So that means we don't have to answer all of them. We have to start with x to the power 0 and reach to the x square. That's what they're saying. So let's start with x, but I can't give x to the power 0 only to x. I have to give to 3 also. So I will start with this. Whenever we do this, we have to write a coefficient, which is the exponent here, c, and the exponent I've given here, 6c0. This is how we do it. And the remaining of the 6 given to the second part of the binomial, which is 1 in this case. Second term is 1. It will get all the 6. So 6 plus 0 is 6. That's what the aim is. Next, we'll go to 3x to the power 1. That means this will become 6c1. And remaining 5 exponents will go with 1. Next, this pattern will continue and we will reach where we want. So it will be 1 to the power 4. So they said up to x square only, and this is x square. So I will stop here. I will not write rest of them. So let's see. Let's try to expand this. 6c0 is 1. This is also 1, and that is also 1. 1 to the power anything is 1. 6c6 will be 6. 3x to the power 1 will be 3x. So let's write 3x like this. 1 to the power 5 is 1, and there is no need to write it. If you want to write it, but it is not going to make any difference to the whole term. So 6c2 will be 15. And 3x squared, that means this square is applied to 3 as well because it is over whole bracket. So it will be 9x squared. And 1 to the power 4 is again 1. Okay. This will be 1 times 1 times 1 plus 6 times 3 will be 18 plus then 15 times 9 will be 135 x square. They were asking us to expand this in ascending powers of x. Done. Up to x square. Done. Okay, let's see if next part has something. Hence, find the coefficient of x square in the expansion of this. So this part is already done here, right? Up to x square, because x cube cannot give x square. That's why they asked us to stop at x square here. So we'll use the same expansion here. So our first bracket is 1 minus 7x. This is b part we're doing now, okay? Plus x square. And the expansion of the second part is here. So I'll write this 1 plus 18x plus 135x square plus something is more, but since we are concerned with only x square, there is no need to write anything else. So what will give, if I multiply 1 with which one of these will give me x square? Obviously 1 multiplied by 135x square. So this is 1 times 135x square, which will be 135x square. Now 7x, we need one more x to make it x square. So 7x, negative 7x will multiply with 18x. X multiplied by positive 18x. Okay, that will be minus 126 x square. And next we have x square and 1, that will give us x square. Just x square. These are the only combinations that will give us x square, no other. Like if I multiply 1 with 1, it doesn't give us x square. If I multiply 7x with 135x square, it gives us x cube. So any other combination, even if I involve the remaining parts, never gives a x square. So we will have to do this. So 135 plus 136 minus 126 is just 10. So we can write the coefficient of x square is just 10. Alright, let's move on to the next question, which is this. A line has equation this one. So it's a line, of course, because its degree is 1, linear function. Okay, and a curve has this cx square plus 3x minus c. So there are two c's in this. Okay, where c is a constant. Okay, showing all necessary workings, determine which of the following statement is correct. Okay, in all these years I've seen this one question like this for the first time. Okay, let's see. So curve has this equation showing all necessary workings, determine which of the following. Okay, so since we have y here and y here, that means we can equate these because they're talking about these y's are exactly same y's. So we will just equate the equation. So let's say 2cx plus 3, that is y here. Cx square plus 3x is here, so we'll equate them. Minus c, and that will give us a quadratic equation. And let me bring everything to the right side because x square is here. So cx square plus 3x minus 2cx minus 3 minus c. Okay, so let's combine the work like once. So cx square is alone, so it will remain cx square, but they have x's. So let's write 3 minus 2c here. So combine them. Now this will be minus 3 plus c. Okay, I have taken minus common from these, so it gives me a quadratic function, which is this will be a, this will be b, I hope there is no, and this will be c in quadratic formula. Okay, showing all necessary workings, determine which of the following statement is correct. The line and the curve intersect only for a particular set of values of c. Okay, so let's to find the point of intersection, we should see how many solutions does it have. Okay, so let's see, for finding solution of a quadratic, we should first look at discriminant, which is b square minus 4ac. So b is 3 minus 2c square minus 4 times c times how can I write this one? Okay, let me again expand this like this, minus 3 minus c. Okay, and I will see whether it is equal to 0, greater than 0, or less than 0. So let's open this one first. So 9 minus plus 4c square minus 3 times 2 is 6, so 12c. So I have applied this particular identity. A minus b whole square is a square plus b square minus 2b ab. So that's what I've done. A square plus b square minus 2ab. I multiplied them and multiplied by 2. Okay, minus 4c times minus 3 will be plus 12c. Then minus 4c times minus c will be plus 4c square. So these two cancel out, they're exactly same. What do we get here? 4c square plus 4c, 8c square plus 9. Okay, this is what I'm getting here. So now I have to see whether it is greater than 0, less than 0, or equal to 0. So you can see that 9 is positive. This c can never be negative because a square is always positive. 8 is positive, that means all three are positive, so we will get a positive result which is greater than 0. That means it has two distinct solution. Now let's see the three statements they have given. Okay, the first one, the line and the curve intersect only for a particular set of values of c? No. If I say 8c square plus 9 is greater than 0, any value of c, any value if I give from negative, say, infinity to positive infinity, any number I give, it will always be greater than 0. So that's not true. The line and the curve intersect for all values of c. That is true. The line and the curve do not intersect for any value of c. No, we have solution, so no, this is not true. So B is the one correct. So which of the following, they're already saying which one of the B is the one which is correct in this case. Good. Let's go to question number 3. The diagram shows a cubical closed container made of thin elastic material which is filled with water and frozen. Okay, though it is elastic, it is frozen. During the freezing process, the length x centimeter of each edge of the container increases at a constant rate of 0.01 centimeter per minute. Okay, the volume of the container at time t minutes, okay, again minutes, so then no need to worry, is v centimeter cube. Find the rate of increase of volume when x is 20. So let's find the volume first. We should make an equation for volume in this case, and volume of a cubicle, so it's a cube, x cube, right? Now we will differentiate with respect to time to find the rate, rather rates. Okay, so I will differentiate only this with respect to time. I'll get dv over dt, and then I differentiate this 3x cube with respect to time. It will be 3x square, and because it is with respect to time, we'll have to write dx over dt. So now let's substitute what they have said. The container increases at a constant rate of 0.01 centimeter per minute. The length increases, the x increases. That means this dx over dt is equal to 0.01. So I'll write 0.01 in place of this. Now the volume of the container at the time t minutes is v centimeter cube. Find the rate of increase of v. So this is what they are asking. So dv over dt when x is 20. So 3 times 20 square. Specifically at this time, what is the rate of increase of volume? So it is 400 times 3, 1200 times 0.01, which is 12. Now unit has to be centimeter cube per minute. Question 4. The transformation R denotes a reflection in the x-axis. So reflection in the x-axis, people mistake it as x becomes negative. No. Suppose this is the one of the points on the graph of that function. When we reflect over x-axis, it will be reflected here. That means the y coordinate, y component which was positive becomes negative. So y is reflected. Actually y changes sign, not x. So if y equal to fx is a function, it now becomes y equal to minus fx because we reflected it. Where? Over x-axis. Okay, just keep in mind that the whole function gets a negative in front. All right. What about the second one? And the transformation t denotes a translation of 3, 1. So translation means the point, whichever point. There are multiple points on a function's curve, but let's focus on this one. What does translation of 3, 1 is 1 means? That it will go 1, 2, 3 to the right. It will increase by 3 and go down by 1. So this point will go here because the translation is 3 minus 1. And our transformations are like this. If y is equal to fx, the new transformed function becomes a f k x minus can I use b? Because people use different alphabets here. Some people use d and then plus c. Right? This is how a function looks like. So what we have done, a reflection is in front of a, it becomes negative. This is one transformation. They're saying there is no stretch, so we'll not include a. There is no stretch in horizontal direction or vertical direction. This is vertical, this is horizontal. There is translation and there is a vertical translation. This is horizontal translation, this is vertical translation. So this and this are involved, these three. No a, no k. So let's read what they're saying first. Find the equation of y equal to gx, a new function of the curve with equation x is y equal to x square after it has been transformed r followed by t. So what is r? R is, okay, reflection, and then followed by t, which is translation. And normally the one I just wrote here, the transformations take in this sequence only. First the stretch or compression or reflection takes place, and then translation takes place. So r and t is no big deal, we can do it easily. So first we have to reflect. So y equal to minus fx, rather since they are saying it is gx, so I will write gx. Gx is equal to minus fx after the reflection r has been done. Now translation, gx will be minus f, and x is equal to f. X has been translated 3 units to the right. Whenever we write 3 units to the right, we don't add 3, we subtract 3. That is the rule for horizontal translation, because the graph starts 3 units earlier, okay, or sorry, 3 units later, not earlier, later. Okay, so this 3 has been taken care of. Now minus 1, there is no change. The whole function which was reflected goes down by 1. Yeah, this was the function gx equal to minus of x, it goes down by minus 1. So minus 1, no change here, only the whole translation goes down by 1. This is the a part. This, what function we'll get this function. Okay, do we have a, yes, we have a b part also. Find the equation of the function y equal to hx. Now new hx, of the curve with equation y equal to x square same. Oh, since it is y equal to x square, I did not change it to x square, so it will be gx equal to minus, now function is x square, so I will write x minus 3 square minus 1. This is the function. Okay, now with equation y equal to x square, after it has been transformed t, translation takes first and reflection takes later. Normally this does not happen. Okay, the sequence is always reflection or stretches first and then translation, but we'll do the opposite one here. So first we will translate x minus 3 and minus 1. So if I want to write this way, it will be actually it is not hx, so I will not write it yet. Okay, and second stage is that this whole function we got will be reflected. So minus fx minus 3 minus 1. The one we got earlier is reflected, and if I open this, it becomes minus fx minus 3, and this is a negative, and negative will make it plus 1. So now I will write this way. hx equal to minus x minus 3 square plus 1. This is the solution of B part. Okay, B is done. That's it. Okay. There is C also. State fully the transformation that maps the curve gx onto hx. Gx, this one becomes hx. Okay. So if I want to make gx, what is the difference? It is the same, no problem. Only the y value has become from -1 to +1. That means the graph has gone in y direction. Suppose this is here. If this is -1, this is +1. So any point at -1 has gone to +1, or any point anywhere else also has gone by the same unit, which is 1 and 1, 2 units. There is a vertical translation of 2 units. There is no horizontal translation because the horizontal part remains exactly same. So we can see that a vertical, or in place of vertical, just write translation. There is no translation in x direction, but there is a +2 translation vertically upwards. So this is how we write the translation. This is what the answer of C will be. Okay, question number 5. Question number 5 says, show that equation 4 sin x, let me write it properly because it may not be visible that well, plus 5 over tan x plus 2 over sin x equal to 0. This can be expressed as a quadratic cos square x plus b cos x plus c. Okay, where a, b, c integers. So we have to find those integers also. Whenever we have such a situation, first we should convert sine tan into sine over x, because we know this is an identity which should be you should be aware of, sine x over cos x, so that both of them will have sine x. So we'll do this one, 4 sine x plus 5 over sine x over cos x, correct? Tan becomes sin x over cos x, but I will not write over cos x. I will write cos x on top. It's the same thing. Denominator of a denominator becomes numerator. Plus 2 over sin x and equal to 0, and that becomes exactly same now. So let's give this also a denominator of sin x forcibly. That means we have to compensate it by squaring the numerator, because sin square x over sin x will again be 4 sin x. So I've not made any change, but because they have same denominator now, we can just simply write 4 sin square x plus 5 cos x plus 2 over sin x equal to 0. Combine all three because of the denominator. Now this sin x goes and cross multiplies with 0 and becomes 0. There is no need, so we are left with only 4 sin square x plus 5 cos x plus 2 equal to 0. And this is what they were asking. Okay, but they are asking cos square x, cos x and c. Cos x and c is there, but this is not cos square x, so we have to change it. So we have another identity, which is sin square x plus cos square x equal to 1. We want to replace this sin square x by cos square x. So we will write sin square x, will isolate. Whenever we want to eliminate any particular term, we should isolate it so that it can be written in terms of the other one, this one. So I'll write here 4 1 minus cos square x plus cos 5 cos x rather plus 2 equal to 0. And if I open it, let me complete it here. 4 minus 4 cos square x plus 5 cos x plus 2 equal to 0, which is minus 4 cos square x, this one, plus 5 cos x, this one, but 4 plus 2 will become 6 equal to 0. However, we do not write minus as the first term. So what can we do? We can change all of their signs because it's 0, right? So if I multiply this whole equation by -1, what do I get? -1 times -4. We are allowed to do that, okay? We are allowed to multiply the whole equation by the same number. It will become -5 cos x, and this will become -6 equal to 0. And they didn't say anything is positive, negative, but it's okay. So yes, this is the one. We got a equal to 4, b equal to -5, and c equal to -6. If you write the opposite, if you write from here also, that is also fine, because both of them work well. Okay, hence solve the equation. So we have to solve the equation we got here, 4 cos square. So let's say let cos x equal to some alphabet t. So what does this equation become? 4t square minus 5t minus 6 equal to 0. So since this is the question and this was changed to this, that's why I'm using this one, not the one that they've given here. So this is my equation. I have to let me change the middle term. That will be easier, yeah, because 6 times 4 is 24, and that can be done here. 8 times 3 is also 24. So this out it will be. In first two terms, we can take 4t as common. So t minus 2 is left. Here we'll take 3 as common, so t minus 2 again. In both of them, t minus 2 is common, so we'll take t minus 2 common now. What is left? 4t plus equal to 0. So this gives me t minus 2 equal to 0, or 4t plus 3 equal to 0. So this gives me t equal to 2, and this gives me 4t equal to -3, and t is -3 over 4. But t was my creation. Actually it was cos. So cos x equal to 2 is 1, and cos x equal to -3 or 4 is second. And if you look at the graph of cos, it is something like this. Maximum value is 1, minimum value is -1. So 2 cannot be the value of cos. This answer can be rejected. This is the only one we will do, where cos is negative and our domain is given as 0 to 360 degrees. So that means if I go to quadrants, cos is negative here and here. Our two solutions will be in these two quadrants. And how do we find them? First we'll find what is cos, which is x equal to cos inverse 3 over 4, not -3 over 4. If you put cos inverse -3 over 4 in a calculator, you get just one answer. But we can see we get two answers. For that, we ignore negative because negative has already given us two quadrants. So we just focus on cos inverse 3 over 4. Let me use my calculator to do this. By the time I'm doing this, I would request you to like this video, share with your friends, and subscribe to my channel, Math United. I'll be preparing many more videos for you in future too. Your subscription will help me make them. Only 8% of my subscribers watch my videos. 92% are non-subscribers. So there's a big gap here. Please subscribe to Math United. What I'm getting is 41.4. So this acute angle here is 41.4. This acute angle is also 41.4, and this is 0 degrees. Our answer starts from 0 and reaches to the lines we have drawn. Since we know this is 180 degrees, so our first answer, x1, I can call it, is 41.4 degrees lesser than 180. So 180 minus 41.4, which will be equal to 138.6 degrees. And second one, 180 plus, because it is after 180, right? It starts from 0 and we reach to the line again. It will be 180 plus 41.4, which is 221.4. Angles are given in 1 decimal places. This will be our answer. The diagram shows a motif found by major arc AB of a circle. Major arc AB of a circle. Which is minor arc? This AB. This dotted line is minor. Okay. Circle with radius R. So radius, we can see this. Center O. Good. The minor arc AOB of a circle also with radius. Also with radius R, but center C. From here also we draw a circle, and this becomes minor arc. So major arc will be somewhere here, which is not shown to us. Got it? And again R. So these both have same radius. Okay, so the point C lies on the circle with the center O. Very good. That means this is also R. Okay. Given that angle ACB is K pi, ACB. Okay, let's try to join this. This angle is how much? K pi. Okay, K pi. State the value of fraction K. Okay, and we can clearly see what is it equal to. Why? Because this is R, this is R, this is R. That means this is equilateral triangle. So angle ACO will be pi by 3, 60 degrees, because it is equilateral triangle, right? So angle OCB will also be pi by 3, and this is also equilateral triangle because this B is on the minor arc of, or major arc also, of center O and of center C also. So this R, then this R. So done. Same. And angle ACB, which they are asking, is the sum of angle ACO plus angle OCB, which is pi over 3 plus pi over 3, which is 2 pi over 3. And if it is K pi, that means this 2/3 is K. So we can say that K is 2/3. Alright. State the perimeter of the shaded motif in terms of pi and R. Okay, this is the one. So let me use this one, this space. So can we say that this minor arc AOB here is a reflection of exactly the same length and reflection of ACB, right? So the perimeter of this plus this will be actually this plus this, which is the full circle, isn't it? Just find the circumference of the circle, and that will be the perimeter. So we can write the perimeter major arc AB plus minor arc AB. Why? Because AOB arc is same as ACB arc, which is minor arc AB, right? So basically the perimeter becomes the circumference, and that's why the answer will be 2 pi R is the perimeter of the shaded part. Find the area of the shaded motif, giving your answer in terms of pi R and square root 3. Okay, so let me bring this particular drawing down there, and I will find the area also. Okay, So now we'll find the area of the motif. Okay, so first what will I do? I'll find the area of this segment, right, and double it. What will I get? I will get the area of AOBCA if I double the area of this one and subtract from 2 pi, sorry, rather pi r square, the whole area of the circle. So my focus is this segment. So let me that part because it has become a little clumsy there. So I will find the area of this segment. So area of segment will be equal to area of sector, whole of it, minus area of the triangle. This triangle if I remove, I'll get the area of the segment I want. So area of segment will be equal to area of sector. What is the area of this sector? If this is R and this angle is 2 pi by 3, because this angle we found that it is 2 pi by 3. It is exactly same because this is a rhombus we have formed. This will be the same angle. So 2 pi by 3 I'm using here. So area of a sector is half r square theta, and theta is 2 pi by 3, which is it making at the center, minus area of triangle is half first side, any one side of the triangle. I'm taking this one, which is r. Second side of the triangle, which is r, and sine of the, let me make some space here. Okay, sine of the angle between them, which is 2 pi by 3. This is the formula for the area of a triangle. If you want to know how we got this formula, or how to use this formula rather, I will give a link in the description where I have solved many circular measure questions, and you can get the idea about this. Anyways, what will this be? This 2 and this cancel, which will become pi r square over 3 minus 1 over 2 r square, and sine pi by 3 is 60, right? Square root 3 over 2. So pi r square over 3 minus square root 3 over 4 r square. Okay, the original plan was that if I find the area of this segment, I will double it, because the white parts are two segments and they are exactly congruent. They are reflection of each other, we can say. So twice of this will be subtracted from the whole circle. So area of the shaded motif will be area of the circle, whole circle, minus 2 times area of segment. So we got the area of segment, this one, we'll just substitute here. So which comes out to be pi r square minus 2 times pi r square over 3 minus square root 3 over 4 r square. What next? We can open this bracket. Pi r square minus 2 over 3 pi r square minus, minus plus 2 square root 3 over 4 r square. Okay, so r square is common in all. Let's take it common. So pi minus 2/3 pi plus, this can cancel, square root 3 over 2. Okay, and finally we can subtract pi minus 2/3 pi will be 1/3 pi. So pi over 3 plus square root 3 over 2. That's what they're saying. Find the area of the shaded motif, giving your answer in terms of pi r and square root 3. Pi r square root 3. Done that. Okay, question number 7. Question number 7 says the sum of first two terms of a GP is 15. So A1 plus A2 is 15. Alright. And the sum to infinity is 125 over 7. So equal to 125. The common ratio R is negative, so it is less than 0. Find the third term of the progression. Okay. So first let's put them in same format. So A1 I will write as A. A2 will be AR. A multiplied by the ratio equal to 15. So if I take A common, 15. So now S infinity, the formula for S sum to infinity is A divided by 1 minus R. So if I substitute, okay, let's isolate A, so that what are they asking? Third term, so both are needed. A and R both are needed. So I will isolate this one. 15 over 1 plus R will be the A which I will substitute here. So S infinity, which is 125 over 7, equal to A. In place of A I will write 15 over 1 plus R, and denominator is 1 minus R. 27, not made any mistake. Okay, so 125 over 7 is equal to 15 divided by 1 minus R square. A plus B, I hope you know this identity. A plus B, A minus B equal to A square minus B square, and I've done same. You can expand this also, you'll get the same thing, 1 minus R square. Let's cross multiply it to get the value of R. So 125 minus 125 R square equal to 15 times 7 will be how much? 130, no, 90, 130, 15. Let's bring 125 to the right side. So minus 125 R square equal to 105 minus 125. So R square will be 105 minus 125 will be minus 20 over minus 125. If we first of all negatives will cancel, divided by 5 will give me 4 out of 25. This is R square, but we want R. So if I square root both sides, I'll get plus and minus 2 over 5. Yeah, square root of 4 will be 2, square root of 25 is 5, plus or minus. But they have clearly said here, the common ratio is negative. The common ratio of the progression is negative. Find the third term. So R is confirmed to be negative 2 over 5. Now, they're asking us to find the third term, and which I will do here. A3 is AR to the power 3 minus 1 using our formula. So A3 is, okay, A is not known to us, so let me find A from here. A equal to 15 over 1 plus R, and R is minus 2/5. So you can put this in a calculator. Let me do it mentally. 3/5, so 75 divided by 3, 25. Okay, so A is 25, R is minus 2/5 to the power 2. Yeah, so which comes out with 25 times 4 out of 25. Answer is 4. Question number 8. The diagram shows the curve with equation this and okay, meeting at point A and B. The two curves are meeting at A and B. By using substitution this, calculate the coordinates of AB. Okay. Since they are at same level, it looks like they are at the same level, their y coordinate is expected to be same. So let's do it. To find the point of intersection of two curves, we just equate the curves. So I will write this one which is 2 minus 2x minus 3 square plus 1 is equal to 2x minus 3 to the power 4. Now, since they are using the substitution this one, I will use u equal to square, 2 minus 3 square. Why? Because it is power 4 also. So this becomes u plus 1 equal to 2u square, isn't it? Because square of square will be 4, and it becomes easy. So 0 equal to 2u square minus u minus 1. Okay, so now we have to find the value of u. So I don't think splitting the middle term will help. Oh, it will help. So we can do that. 0 equal to 2u square minus 2u plus u minus 1. So 2u taken common. What do we get? U minus 1 plus 1 u minus 1. So we get 2u plus 1 u minus 1 equal to 0. So this gives us 2u plus 1 equal to 0. This gives u minus 1 equal to 0. This gives u equal to 1, and this will be 2u equal to negative 1 and u equal to negative 1 over 2. Let's reject this one because u was 2x minus 3 square. 2x minus 3 square equal to negative 1 over 2. And a square number can never be negative. So that's why I'm rejecting this one. This is the only one I'll have. So I'll write 2x minus 3 square which is equal to 1. So let's expand this by the same identity we used earlier. A minus b whole square is a square plus b square minus 2ab, and that's what I'm going to do. A is 2x for me. So 2x square plus 3 square minus 2 times 2x 3 equal to 1. 4x square plus 9 minus 12x equal to 1. So our quadratic equation becomes 4x square minus 12x plus 8 equal to 0. Yeah, the 1 goes there. 9 minus 1 is 8. And we can divide this whole equation by 4 to simplify our mental calculation. So x square minus 3x plus 2 equal to 0, and let's finish it here. How can I break this? Yes, I can. X square minus 2x minus x plus 2. This is what I can write this as. X is common here. X minus 2 minus 1, x minus 2 equal to 0. So what do I get? X minus 2 is common in both. Remaining is x minus 1. So this gives us x equal to 2. This gives us x equal to 1. And that means the smaller number is 1 comma something. Bigger one is x is 2, right? 2 comma something, and that something seems to be same. But let's see what is that. So if I put x equal to 1 in the main equation, this one, what do I, or rather one of the equation, not both, one of them. So let me use the easier one, this one. Okay, when x is equal to 1 in this, so 2 times 1 is 2 minus 3 to the power 4. Okay, this is minus 1 to the power is 1, so it is 2. When to y equal to, okay, when x is equal to 2, I should get the same answer. 2 times 2 is 4 minus 3 to the power 4, which is again 1, 4, 1, 2 times 1. See, we got the same y. So it is 1, 2 and 2, 2. These are the two coordinates of A and B. And this is just the A part. That means there is some B part also. Find the exact area of the shaded region. So what will we do? We will find the area under the shaded region by putting some straight lines here. So if I find the area under this curve, the upper one, this curve, I'll find this whole area, right? Which will include this white part also. And white part is nothing but the area under this lower curve. So I will find the area under the lower curve also, and which will give me the white part, and I will subtract it from the first one, and we'll get the answer. Hopefully there will not be any problem. So let me write both the equations here. What I'm going to do, that is the plan. From this is x is 1, this is x is 2. From 1 to 2, I will find the area under the first curve, which is 2x minus 3 square plus 1 dx, and then I will subtract from 1 to 2 the different integration of this one, 2x minus 3 to the power 4 dx. Okay, so let's do it step by step. So first I will focus on these limits later. First I will just integrate this. So integration of this one, because it's a linear function, it's easy. It will be 2x minus 3 whatever is inside bracket, and then we will add 1 to the exponent and divide by the same exponent. Further we will divide by the differentiation, not integration, differentiation of this. Differentiation of minus 3 is 0, so ignore it. Differentiation of 2x is 2. Okay, integration of 1 will be just x. So basically we have already integrated. I can write plus c also, which is from 1 to 2, minus let me keep 2 out of this, so I'll put 2 outside. It will be same thing here, just what I did there, 2x minus 3 to the power 5 over 5, again divided by the differentiation of this, which is 2 again, and there is nothing here, plus c, rather d, let's make it d here, and from 1 to 2. Let's substitute one by one. First I will substitute 2 in this. So you can use your calculator. I'm doing it mentally again. 2 times 2 will be 4. This will be 4. 4 minus 3 is 1. 1 cube is again 1. So 1 over 6. Then substitute 2 here. So 2. There's no need to include c because it will get cancelled in both substitutions. I'm ignoring it. Then substitute 1 in this. So 2 times 1 is 2. Minus 3 is minus 1. And minus 1 to the power cube is minus 1 over 6. Plus. What? Rather, we'll have to do minus, okay? Since we are substituting 1, it is to be subtracted. So since, let me put minus here. Now it is fine. Minus 1, 6, and this is plus 1. Okay? Since I put a negative here, so no need to include it here. Done. The first one done. Minus. And it will be 2 times, substitute 2 first. So 4 minus 3 is 1, again 1 over 10. And nothing else. Minus, if I substitute 1, it will become 2 times 1 is 2, again minus 1 to the power 5 is minus 1. So minus and minus will make it positive, 1 over 10. D is excluded again. Okay, so simplified, 1 over 6 plus 2 plus 1 over 6 minus 1 minus 2 times 1 over 10 minus 1 over 5 minus 1 over 5 again. What is their LCM? 30. So 5 plus 60, yeah, because it doesn't have any denominator, and 30 I've taken as LCM. 6 times 5 minus 30 minus 6 minus 6. Okay, positives 5 plus 60 65 70 minus 42. Yeah, 30 plus 6 36 42 over 30. That gives me 28 over 30, and if I simplify this, I get 14 out of 15, which is the area of the shaded part. Voila, done. Next. 9. Express this quadratic expression in the form of this, which is vertex form or completing the square form, where a and b are constants. Okay, so let me tell you a way I do it. You can do it any different way. Some people find minus b over 2a as the vertex x coordinate and then do it, but I'm doing it different way. Okay, so I'll separate these two by taking 4 common. So 4 x square minus 3x. Okay, I'll put some space here and write 13 outside. Since 4 is not out of 13, so it is unaffected. Okay, now we do add half of this 3 over 2 square. Okay, I add it from nowhere, I just added it. But if I've added, then I have to subtract also. So I will subtract here 3 over 2 whole square. Okay, but mind it, if I added this here, it got multiplied with 4 also, so I have to write minus 4 times 3 over 2 whole square. And now it will be a perfect square, a square minus 2ab plus b square. So x, we take the sign of the middle one, and 3 over 2 square. This becomes a perfect square, and now it becomes 13 minus 4 times 9 over 4 square of, this is 9 over 4 and 4 cancel, so 4 x minus 3 over 2 square plus 13 minus 9 is again 4. So they want this format 2x plus a. That means I have to bring these two out. So I'll do what? I will write 2 over 2 here so that it have same denominator and we can combine them. So 4, and they do not want, okay, I'll have to do different idea because they do not want anything in front of this. That means this 4 should also go inside. Okay, so can I write this as 2 square, 4 as 2 square, and then it remains what it is, plus 4, right? Now since both of them have squared, then whenever two have squared, we can combine them by multiplying the bases, whatever the bases are there. So 2 multiplied with this 2x minus 2 multiplied by 3 over 2 is minus 3. Done. And plus 4. Okay, so please keep in mind, whenever the rule is this: a square times b square is ab whole square. That means a and b multiply, and I multiply 2 with these two. That's how I got this. So we got a equal to, and this is plus here, I'm getting minus, so I'll have to write minus 3. Then b is 4. Minus 3 and 4 are the answers. If I would have not taken this 4 out in the initial phase, that would also help, but this I think is okay. It should be 4. Okay, now it matches. Alright, so that's the function where x is between p and q, they are constants. The function g is defined by gx, okay, for x is less than 8. Okay, given that it is possible to form a composite function gf, find the least possible value of p and the greatest value of q. Okay, so gf, they're saying gf, so the parent function is g and we are putting fx inside it. Okay, so g is 3x plus 1, so I will just write 3, and in place of x, because it is gx and I'm writing g fx, I will substitute by fx. So in place of this I'm writing 3 times 4x square minus 12x plus 13, and then we have plus 1 also. So can you see, in place of x I put fx, and in the original gx they have said that x is less than 8. Since x is replaced by fx now, that means 4x square minus 12x plus 13 has to be less than 8. And we in previous part we did change it to this 2x minus 3 square plus 4. So it will be 2x minus 3 square plus 4 is less than 8. So 2x minus 3 square is less than 8 minus 4. 2x minus 3 square is less than 4. If we square root both sides, we'll get a positive and a negative, right? So if I square root, it will become, the negative of this will become here, and we'll get a range here. 2x minus 3 is less than positive 2. The one negative will be lesser than this and positive will be more than this. So let's add 3 to both sides. So what do we get? Positive 1 less than, this cancels, 2x less than 5. Divide all 3 by 2 and we get our answer, which is half is less than x is less than 5 over 2. This is the least value of p, this is the greatest value of q. That's what they're asking. Yeah. Next, find the expression for g of x, and we found it, this one. So let me keep it visible and do it. So we'll expand just this one and we'll get g of x. So we want an expression for this. G f x will be 3 times 4, 12x square minus 36x plus 39 plus 1, which is 12x square minus 36x plus 40. That's the expression for g f x. Okay. The function is defined h. Okay, different is x square minus 12x when x is less than 0. Find the expression, and again it is x square. I think it is should be 4x square. Okay, so we can write this one. And what was the conversion here? 2x minus 3 square and then plus 4. This was the conversion of this, right? We want to find its inverse. So let's say this is equal to y. And this vertex form or completing square form is the best way of finding inverse. So first thing first, for inverse we should always switch the x and y. So x equal to 2y minus 3 square plus 4, and I have to isolate this y, which will be the inverse. Okay, for that this 4 should go there first. So x minus 4 equal to 2y minus 3 square, and if we square root this side we will get plus and minus here. This is square and square root cancel out. So what do we get? 2y minus 3, which was this, equal to plus minus square root x minus 4. So 2y is equal to 3 plus minus square root x minus 4. Minus 3 came here, and it will be y. Y will be equal to, we'll divide both sides, y equal to, we can do this one, right? And divide here, cancel, y equal to 3 plus minus square root x minus 4 over 2. Now it's an inverse. We can't have two values so that it doesn't become an inverse. So that means we have to isolate plus or minus one of them. So what was the original domain given to us? It was this. It is between minus half and 5 over 2. This is what x is, right? So because that's the original one, that means the range of this one will be between 1 over 2 and 5 over 2. How is that possible? If I do 3 over 2 already, yeah, 3 over 2 and plus square root x minus 4 over 2. Some good big values of x will cross 5 over 2 because that was our upper limit. That means we can't add, we have to subtract, and that's why I will ignore the plus in this case, and I will write that, or in place of this I can write f inverse, and rather h inverse. H inverse x is equal to 3 minus square root x minus 4 over 2. This is the function. Okay, question number 10. It says a curve has a stationary point at this such that d square, the second derivative, is 6x. So find dy over dx. So whenever we have a stationary point, so suppose this is the curve, this is a stationary point where the gradient dy over dx is 0. This is also a turning point or stationary point where dy over dx is equal to 0. That means if I somehow go to dy over dx, I can make it equal to 0, right? So to find the dy over dx from second derivative, we can integrate this one. For first, let me rearrange it. So can I write this one as d square y equal to 6x dx square? And if I integrate both sides, this will become dy, this will become 6x square over 2 plus c dx. Okay, and now I can write again, cross multiply, this dx comes there, dy over dx is equal to 3x square plus c. Okay, they said this is a stationary point. That means at x equal to 2, y is useless here, x equal to 2, dy over dx is equal to 0, and this fact we will use to get the value of c. Dy over dx is 0, x is 2, so what do we get? C equal to 4 times 3, 12, so minus 12 equal to c, and this what we will use to complete our equation, this one, dy over dx equal to 3x square plus, not plus, minus 12. This is dy over dx. Find the equation of the curve. Now we have to find the equation of the curve, and for that again we'll have to rearrange. So dy, this b part, equal to 3x square minus 12, and dx comes back. Okay, and we can integrate both of them again. So y is the integration of dy, and this one will be 3x cube over 3 minus 12 x plus new constant, call it d. 3 and 3 cancel, and we need d. Y equal to x cube minus 12x plus d. And to find d, we know that if x is 2, y is minus 10. So y is useful here. So we can write when x is 2, y is minus 10. So let's substitute here. In this one, y is minus 10 plus equal to 2 cube minus 12 times 2 plus d. Keep d here, and this is minus 24, this is 8. So minus 8 plus 24 minus 8. Yeah. So minus 18 plus 24 is 6. Yeah. So d is 6, and our equation is y equal to x cube minus 12x plus 6. Do we have some more? Yes, we have C part also. Find the coordinates of the other stationary point and determine its nature. So since we already know that one stationary point is available, which is 2 minus 10, yeah, it's a cubic function, it will definitely have two turning points or stationary points. One of them is available to us. So let's say which one is the second one. So we're doing C part, and we can write that the for stationary point dy over dx has to be equal to 0, and dy over dx was known to us in previous part, which was 3x square minus 12. So it gives me 3x square minus 12 is equal to 0, equal to minus equal to 12, x square equal to 12 over 3, which is 4, and if I square root both sides, x is plus or minus 2. Plus 2 is already known to us. Now we can find the other one. When x is minus 2, we'll use the equation we got here. Y is equal to minus 2 cube minus 12 times minus 2 plus 6, which is minus 8, right, plus 24 plus 6, which is 22. We can write the other stationary point is x is minus 2, y is 22. Okay, next one. Find the equation of tangent to the curve at point where curve crosses y-axis. Curve crosses y-axis. So this is the curve. Where does it crosses y-axis, right? That means y-intercept they're asking. So x cube minus 12x plus 6. Our equation of the curve. So this is D part. Equation of the curve equal to y equal to x cube minus 12x plus 6. Let me confirm. X cube minus 12x plus 6. Okay. Okay, so they're saying crosses y-axis. That means they're asking y-intercept. Y-intercept. For y-intercept, x is always equal to 0. So y equal to 0 cube minus 12x plus 6. 12 times 0 plus 6. 12 is gone. 0 gone. Y equal to 6. So what is the point? 0, 6 is the point where curve crosses y-axis. So equation of tangent, that's what they're saying, right? At 0, 6 will be normal formula y minus y1 equal to mx minus x1. So y and x are general forms, so general points, so we will not touch them, but y1 and x1 are the coordinates of the point where the tangent is passing through. So this will be minus y, this will be 0, and m is unknown to us. So we'll find m now. M is nothing but dy over dx, and dy over dx at x equal to 0 will be what? 3x square minus 12. This was the one now. Dy over dx was x square 3x square minus 12. Yes, it was 3x square minus 12. So 3x square minus 12. So that is minus 12. So equation becomes 1 y minus 6 equal to minus 12 x. So we can rearrange it. We can write y equal to positive 6 minus 12x. That's the equation of the tangent. Next question, number 11, and the final question. The diagram shows a circle with the equation this. Okay, that means if the center is somewhere here, yes, the coordinates will be, because x minus 4 square plus y plus 1 square equal to 40 means 4 and minus 1 are the coordinates of center. That's how we interpret from the equation. And 40 is rather square root 40, right? Square root 40 is the radius. Let me write here. Square root 40 is the radius. Okay. Parallel tangent, each with gradient 1. Okay, so m is equal to 1 drawn at points A and B. Okay. Find the equation of the line AB, this line AB, and this will pass through the center for sure, because the lines are parallel. Only the tangents are parallel on the opposite sides of the diameter. That's what I can say. Find the equation of line AB, giving the answer in form of y equal to. Okay, so just now in question number 10, we'll use y minus y1 equal to mx minus x1. So it will be y minus 1, yeah, equal to mx minus 4. Now m is the problem. For m, we know the gradient of the tangent, and we know that the diameter makes 90-degree angle with the tangent. That means this m will be negative reciprocal of 1, which is negative 1. So our equation becomes y plus 1 equal to negative 1x minus 4, and we want this format, so keep y here, open this bracket, becomes minus x plus 4, and this plus 1 will come here. So y equal to minus x plus 3. That's the equation of the line AB. Find the coordinates of A, okay, giving each coordinate in surd form. Okay, so let's do it here. B, x minus 4 square plus y. Y is now minus x plus 3. And then we have plus 1 also. Square equal to 40. So we get x minus 4 square plus 4 minus x square equal to 40. So you can notice that this is a minus b whole square. This is also a minus b, only their positions have changed. But if you notice, even if they change their positions, they are exactly same. A minus b whole square will be same as b minus a whole square. That means these two are exactly same. We can write 2 x minus 4 square equal to 40. Get rid of the 2. X minus 4 square equal to 20, and square root both sides. x minus 4, because square root and square cancel out, equal to plus minus square root 20, and x equal to 4 plus minus square root 20. Now out of plus and minus, which one will be the smaller? Because we want the smaller x coordinate, yeah, because a is on the left side, and obviously that one is 4 minus square root 20. Square root 20 can be written as 4 times 5, so 2 square root 5. Okay, now we want y coordinate, and y we already have this one, minus x plus 3. So y equal to minus x, which is 4 minus 2 square root 5 plus 3, and that will be 7. No, minus 4 is this one, no? Minus 4 minus 4 plus 2 square root 5 plus 3. So this comes out to be how much? Minus 1. 2 square root 5 minus 1. This is the y coordinate. This is the x coordinate of point A. Find the equation of the tangent at A, giving the answer in the form y equal to mx plus c. Insert form again. C. Y minus y1 equal to m x minus x1. So y and x remain same. We'll put the y coordinate, which is this, 2 square root 5 minus 1, equal to gradient they have given for the tangent already, 1. So we'll write minus the x coordinate, which is 4 minus 2 square root 5. Can we somehow simplify this? Y equal to, okay, we'll open this one. 1 times x is x. 1 times this will be minus 4 minus 2 square root 5 minus 4 plus, because the whole x was subtracted, no? So this will be in a bracket kind of, and because of opening it will become plus. Okay, plus 2 square root 5 plus minus 1. Because of this, minus will become positive here. No change in these signs. So y equal to x minus 4 and minus 1 is minus 5 plus 4 square root 5. This can't be simplified further. And that concludes our solution video for this exam. I hope you liked it. If you did, give it a thumbs up, share with your friends, and subscribe to Math United. Thank you very much.